Hi again, and I think I owe you a story. when Gabi invited me, she said that she has a lot of people that are talking about low-level stuff, and she wanted somebody to talk about something high-level. So I thought you can't get more high-level than software ecosystems, and I wanted to give this talk. And the title of the talk is inspired by this book that I received as a present once. It's a book that's titled What I Talk About When I Talk About Running. Doesn't sound that repetitive as my title somehow. And it's by Haruki Murakami. I didn't read anything else by him, but I was amazed to see that you can write an entire book about your running training and running marathons, and it can be interesting. So, for those of you that like running and long distance running, it's actually an entertaining book. I mentioned already yesterday, my background in research is software analysis. And just to give you an idea what I understand by that, and because I also owe you a presentation for yesterday, I thought I would do a demo of this tool that I called Software Not. I started working on this a long time ago when I was doing my PhD at the University of Lugano. And I'm still maintaining it at the moment. Okay. So I could do something like this. It's the cable. Okay. Yeah, now it works. So, do you hear me? I'm going to say very important things, so so please follow. Okay, so yeah, you see, this is a VisualWorks tool, and I have this awesome icon here called S from Software Not. The window is divided in, here I have some models that are loaded. Let's pick one and play with it. Let's take Argo UML. First thing you see, it's the package hierarchy of Argo UML down here. This is just giving you an idea of the complexity of the system. If you look at Software Not itself, it's much simpler. If you look at Lucene, it's more complicated, and so on. Going back to Argo, the way it all started with me wanting to visualize dependencies between packages, and I had used some other approaches, and you just get too big a mess when you have a too large system. So then I thought, okay, I'm just going to aggregate all the dependencies up on the package hierarchy, and then you get this beautiful view, which is not a mess anymore, but you don't see anything either. So you want to go down into the package tree until you see something. Now I went down into the package tree, and I'm looking at all the packages that are in green here. And this already tells me that there's one large package UML that depends on almost everything else. One of the strongest dependencies is to the UI. That's quite funny, actually. And there's also the reverse dependency. I can inspect the dependencies. I think that's important. And while I was working on this tool, in like the next desk in my office was Ricky Vettel that was working on the Code City, the tool that it's very similar to what Igor was showing earlier. And I think that's really awesome, and in a way it scales much better because dependencies can actually be a mess. So if I I take this package and I expand it again, I get more dependencies, and if I take, if I dare expand UML, it slowly gets quite messy. So what you need to do is you need to use filters, and then you can say, well, I have a bunch of filters predefined here, and I can say, show me all the dependencies that were there for the entire lifetime of the system, and that's filtering. Actually, this is what I'm hiding, so I want to be showing these things. And I promise you that in my office I have a bigger monitor than this. So, you know, what I see here is that some of the dependencies in the system, you know, were there from the beginning, and some were not. And one other tool that's quite important when you do this kind of analysis is being able to save some of the views that you found useful. So, for example, I have saved here. This is inside the UML package, and only that package. And there are fan out inside UML. Well, this one, I guess, I should. Add the highlighter. This highlighter thing, it's quite useful. Huh? Why is that menu going out of my window? So the highlighters, and especially fan out, actually, it's quite a useful tool for getting an impression of where are the important classes in your system. Over and over again, looking at systems, you figure out that the classes with the high fan out, although we all know they're not very, it's not a very good design strategy. What are the active projects on GitHub? And here most are Java projects ever, and they wanted to see. I was just looking at Clojure, and I said, "Wow, Clojure! It's everybody talks about it. Can we have a look and see, you know, how complex it is?" And I copied that Git, and then I downloaded it, and well, it downloaded from earlier, so I can download it again. It's building a model of it, and this is all basically Moose analysis again, so importing the model and building the FAMIX representation. That's not the goal of software nut. Okay, we've got Clojure, and it's got a bunch of well, actually, if you look down here, it doesn't have too much of a package structure really. So, you know, you've got the lang package that depends on ASM, and if we look at the fan out of the classes, you can see that there are, you know, the compiler, it's a class that's using a lot of the other ones, RT, I don't know what's RT, and a few of the other ones. We can go all the way to our favorite, you know, code editor and look at the code. We don't want to read it now anyway. We can see how strong are the dependencies between these two classes, between these two packages. I can see, you know, what are the basically the lang is using mostly the generator adapter, and I can go down to see down to the method level and so on. I can with Argo, I have an example where I can pick a certain package, for example, like let's take persistence. For Argo, I have multiple versions that I have loaded, and I can actually do multi-version analysis. And for example, I have this thing, it's another visualization that I call the evolution film strip, which shows me how the structure of the package evolves over time. And conventions are, I think green means, you know, the class was growing in that version, red was decreasing, and yellow, it was newly introduced. So what we see that at the beginning, they used to have only two classes in that package, the DB writer and the DB loader, and then suddenly all those two disappeared, and a bunch of XML and other parsers and other formats appeared. So they switched from having, I guess, a DB backend to using file-based persistency. You can play more and with it. I think time flies, and they shouldn't spend much more time on it now. So that was what I understood by, but what I understand by, you know, software analysis. And then after some time, I kind of got bored of doing this, and I said I don't want to be analyzing individual systems anymore. It's fun, but I want to do something else. So I said, In the meantime, I was listening to the podcasts of this organization from California called the Long Now Foundation. I see Martin is smiling, and it's an awesome organization. Their idea is trying to encourage people to think long term. And in one of the first presentations they had this beautiful story that some of you already heard, but I'm going to tell it again. About how the old ancient Japanese, when they built a temple, together with the temple, they also planted a forest behind the temple. So hundreds of years later, when the wood in the temple would break down, you would have where to take the wood from to repair it. And they're saying, we don't do that much long-term thinking nowadays. So we have this organization. We encourage to have people that are coming and talking about how to foster long-term thinking. And I was listening to the podcasts of these guys, and they had this really cool one by Stefan Lansing, 1,000 Years in Bali. Stefan Lansing was talking about how in Bali, in this island, they have a very interesting religious system where they're mixing. It's an agricultural religion somehow, and the entire religion ritual is actually determining the rhythm of agriculture. Main agriculture product in Bali is rice, and there's some kind of, the planting of the rice is synchronized by this giving away of holy water that's from some temple up there. And it worked quite well for hundreds and hundreds of years. Everybody was planting at the same time, and the benefit of planting at the same time was after everybody was collecting at the same time, and after they collected their rice, they would flood the rice paddies, so no insect would find any food, and the insects would die. And in the 70s, the Ministry of Agriculture decided that they should decouple, this religion thing with this agricultural thing, and they started using fertilizers and pesticides, and they stopped following the ancient rituals. And what happened was that everybody started planting whenever they felt it was a good time, and there was always a crop growing, and eventually the insects thrived. And after a few years of trying this, they actually went back to the old rituals. Continuation of the story was that people still used fertilizers, and the fertilizers basically eventually were washed into the river flows into the ocean. Too much fertilizers ends up having too many bacteria in the corals. Some of the most beautiful corals in the world die. So this is a story of how a small change in one part of the ecosystem influences a completely remote part of it. So at some point I was thinking, well, this is the natural ecosystem. Maybe we have something like that also in the software. Do we have software ecosystems? What happens if I make changes in my part of the system? Do I break somebody else? And I know we are doing some interviews with people that are working in this kind of large software ecosystems, and one of the developers that was working in a bank was talking about how when he makes a change to his library, people it gets like the compiling of their source code, it's outsourced to a different country, and the results of the compilation come back like 2 days later or something. So for 2 days he doesn't know whether he breaks the code of somebody else or not. I thought that was amazing. So then I was thinking, maybe we need more, maybe we need tools for taking care of the software ecosystem. And as a starting point, I thought, okay, I could just try to take some case studies and see what do I see there. And I was in a visualization group, so I thought, well, what about visualizing things? And I also like programming, so I wrote this tool that was called the Small Project Observatory. It got a prize at NSUG some time ago, but in the meantime, I'm not maintaining it anymore. Some of the things that you could do with it, though, were look at dependencies between projects, look at how the size of the projects was evolving over time, look at try to extract collaboration between developers, tried to see the history of the developers' activity in the ecosystem. And I'm going to show you some of the things that I've seen. For example, this is the difference between the way people collaborate in academia and industry. Academia, you see here, a lot of the people work alone. Some people collaborate. This is a research group, the research group where I'm now, actually, and I was doing this study before I went there. And it's normal because in a research group you have a lot, you have master students that come in, work on their project, and they move on. And then you have PhD students that they collaborate a bit, and some people are working more with others. On the other hand, we also looked at a software company, and they basically, like, everybody is connected with everybody. And I went and asked why. So the way we are really looking how we define collaboration here was looking at people that commit on the same file. And I asked them, is everybody really working on everything? And they said no, but we rotate people on the projects. So after a certain period of time, we shuffle people around such that everybody knows about all the projects. And so that's what we are seeing here. Then we looked at how this was just a cool visualization, basically. Like these 900 developers in GNOME for 10 years, and the developer timelines, the color is different for every developer, it's just for beauty. The lines, the developer, the vertical order, it's arranged in such a way that people with similar activity patterns are clustered together. And what you can see is a few, like, the big chunk of people that are working for a long period of time up at the top, and then, groups of people that come and go, and then most of, I guess it's a little bit of the 20-80 rule. Most of the people have small contributions, and then they move on. This was a project dependency map, again, for the ecosystem in software composition group in Bern. And what you can see, there's the color is the active number of commits per project, and dependencies are, this is VisualWorks. I was only looking at the projects that are actually VisualWorks projects, and this is back in the day, basically. And the dependencies are prerequisite declarations in VisualWorks. So there are some problems that we figured out while looking at these things. First of all, the dependency declarations, the way the system works in VisualWorks, you can declare things that you depend on, things that actually you don't depend on. And you can, and even if, I think you can also get away with actually not declaring things that you depend on. I don't know if I'm correct, and it might be different in the meantime. And for sure, even if you know that there's a dependency, you can't do cool things like what I was showing earlier. And like, at the intra-system level, you just click on a dependency, and then you see all the colors and all the callees. And it wasn't easy to do this. I mean, surely you can do it. So I thought, well, it would be nice to have more information there. Modeling the entire ecosystem the way we did it, with having a FAMIX model of every individual version of every individual system just doesn't scale, so that was a bad idea. And the human collaboration viewpoints, this was cool, but I didn't really like it because it encourages people to make comparisons and say, like that guy works more than the other guy, and that's not my business to show. So I thought I don't want to work on that anymore. Then kind of to address a little bit point one here, we went on and looked at can we take an entire ecosystem and automatically extract dependencies between systems. And we said, let's just take a very simple heuristic and say that if a project declares an artifact called foo, and there's another one that uses that artifact, there's a dependency between the two of them. And we did that on a subset of quick source. And what we came was that it was working quite well, but not perfectly well. And the reason for that is Now, here was the part where I was showing the movie with the criminal penguins, but the internet didn't work, so I couldn't preload it. So it's a funny movie about how penguins are stealing from each other stones, and the morale was that, you know, developers copy code from each other, and that was what was breaking our algorithm, because you don't, very often, you don't have only one place where an artifact is defined, because I think we saw that a lot with a few frameworks. Everybody like takes the entire framework and drops it in their repository. So then I think we could have done more, but we didn't go further here at the time and see, you know, what's the kind of trace the way, look at the time when the files were added to the repository, and then trace how they, you know, trace the source. Okay. So I think I might even have shown this slide yesterday. Then we said, okay, so the thing that breaks our analysis is cloning. Let's look at the cloning. And I think I also owe you since yesterday an explanation of how do we do the type 3 cloning. And before I go there, this is, these are type 1 clones. This is literal copies. And this is a chart of, you know, for smaller methods, there are a lot of clones, and for larger methods, there are fewer clones, basically. So this is how we do the type 3 cloning. It's inspired by detection. It's inspired by a paper by Broder. It's an algorithm called shingles. It's quite a cool idea. He used it for detected duplicated, or he used it to detect similar text. So you have a sliding window that goes over your document. In this case, the sliding window is 2. You take 2 tokens and you create a hash of them. And then you slide the window over the entire document, you create a bunch of hashes, and then because you don't want to have precise matching, you drop some of the hashes. So in his case, he sorted them and then took top. And in our case, because we wanted, yeah, I mean, you need to have we just wanted to drop 25% of the shingles. So what we did was look at the last 2 bits of every hash, and if the last 2 bits were 1, 1, we'd just drop the entire hash. So, and that one turns out that works quite well. Somebody came to me yesterday and mentioned this thing, which is a very cool observation, because I was talking about cloning in Quicksource and how, you know, it's a sign of reuse. But it might be, and this is something that we still have to look at, and I think it's interesting, it might be that it's not necessarily voluntarily cloning. It might be that some people are actually, I might just be repeating something that Hernan does, just because it's maybe, you know, the framework I'm using is forcing me to do kind of the same thing. And, you know, when I do this, when I repeat myself, I create an abstraction, and I create a method, create a class, I know that. But if I repeat what Hernan is doing, and Hernan is repeating what Andres is doing, then we can't know that we are repeating each other. So I think there might be instances of this situation where we are all doing the same thing over and over. And this is something which could be cool to try to detect at the, you know, at the ecosystem level. Right, that's what I was talking about. And this is work that we're going to present with Romain and Rob next week at ASC. It's about trying to see, eventually trying to figure out whether this thing of, you know, how big are these ripple effects in an ecosystem. When somebody makes a changes, how many people are really reacting to it. And we took, again, as a case study, Quicksource, and we had the model which allowed us to take for every version of every system. This is very similar to what Dale was telling me that he was doing. For every version of a system, we look at what are the things that you know, are provided in that version and what's required in that version. And then we just integrate this over all the projects, all the versions, and all the systems. And this is, for example, things. These are things that we can detect with this model, over time, the usage of the classes fill in the blank and UI manager. You know, one is decreasing and the other one is increasing because one was replacing the other. And we are thinking that it could be cool, and maybe with a bit more effort we can, we could provide this information. Or it could be cool to have this information. When you're looking up and you're starting to use a class, it would be useful to know that you're actually using this thing that's on the downhill, and maybe it would be useful to know what's replacing it at the moment. This is an example of a ripple effect. Oh yeah, what's a ripple effect? A change in the API of a system which propagates to other systems. And this is, for example, in 2009 method packaged in is deprecated, and the suggested replacement is the parent package. So what you see here is every timeline is a project, and for every version of the project I'm looking particularly for this method. And if the method was removed, then I have red, and if the method was added, then I have green. And for every one of these two methods that are involved in the deprecation. And what you can see here, for example, is that first one, packaged in, removed, parent package added, removed, added, and the same thing there, but it's not very clear. And then you see this other project that reacts to it, and basically in the same time does the same change, and then kind of reverts it, and then does the change again, but these are a few months later. And this is a few months later. And you can see kind of the reactions to such a change are all over the place. And in the paper we go on and we look at how big are these effects, how many projects are reacting. In the outlier case to such a deprecation, there's 80 projects that are reacting. There's more developers in those projects that are reacting. In average though, or it's not that many, so that it's not such a. Actually, we were hoping that we would discover that this is a really, really big problem and we need to address it. And it's not an amazingly big problem. I mean, the effects are quite scoped for what we are looking at least. While looking at this, we also found some funny examples of conversations on the mailing list. So somebody is saying, I was looking that for this classes, I'm wondering if they have been dropped. And then the developer says, well, yeah, they have been dropped. A mail went out to this list if anybody still used them, and nobody replied. Personally, I don't know of any application that uses these dialogues. So we are thinking this is happening very often, that you as a developer, you don't know how other people are using your code, and you might want to know. And I guess first it would be useful for your self-confidence, happiness. There are a lot of people that are using your code, and second, it might help you in designing better your API maybe. Okay, so yeah, what do I talk about when I talk about software ecosystems? We are interested in the source code, and this is as opposed to there's kind of a different community of people that are using the term, and for them it means a business perspective. How do you have your business thrive in the context in which there are many other businesses that do software? And that's a very interesting perspective, I guess, but it's not ours. And yeah, we're interested in the source code, in what kind of analysis can you do when you take really the entire big picture. I think that was all I had to say, and I was talking too much already. So thank you for your attention. If you have questions. Okay.
The tool is not a software component. Okay? When you have the styles that you have on your right.
Yeah. Here.
Yes. How do you decide that this general adapter or whatever? Is it because it's something that is recurring several? You know what I mean? I have seen there you have a kind of identified like patterns.
Okay. No, there's like that. Those are not patterns. This thing here, it's just the GUI for letting you basically, now I'm looking at now I'm setting filters for relationships. Now I'm setting filters for entities. Now I'm highlighting things. But there is no pattern detection included. There's some other stuff, but unfortunately, that's not there. It would be a cool idea.
How do you decide that the visualization system is useful? I mean, it's just yes or another visualization?
I think the way you do I think visualization is a lot of an art, and if you want to make it less of an art, then you probably want to go into usability land and try it with people and get feedback. I also think that often visualizations help you discover things that you didn't know, and this is why basically a framework that allows you to explore different ways of looking at things, it's useful, like Alex was showing yesterday. I also think that very often a visualization is useful. Like the way you should use some visualization is to invent them, use them, and then throw them away. Because like, for example, the example that Alex gave yesterday with the tree, the profiling example where you had like the big yellow things that were at the bottom, and that was an insight which probably otherwise you wouldn't have, but once you have it, then you should be able to, or often you'll be able to quantify it, and next time you don't have to kind of open the visualization again, but you can just detect it automatically. You still need visualizations, but like a subset of visualizations are useful, and then you have to throw them away. Okay, thank you.